In this video, we are going to learn about the integrals of sine and cosine functions when they are given with some powers. Let us look at their formulas first. The integral formulas are same as the derivative formulas except the change of sign. The derivative of sin x is a positive cos x, but the integral of sin x is a negative cos x. The derivative of cos x is a negative sin x, but the integral of cos x is a positive sin x. So they are easy to memorize, just the change of signs are there. Now let us start with the basic examples. These problems can also be solved using u substitution, but we can also use these short formulas. These formulas are used when we are given sine and cosine functions with some constant inside parenthesis. For example, we need to find the integral of sine 5x. We know that integral of sine is negative cos. So first we write negative cos of 5x divided by the derivative of 5x. The derivative of 5x is 5, which is the constant given along with x. So you just divide the function by 5, by the constant. Same way, for example, you need to find the integral of cos 4x. We know that the integral of cos is sine. So it's sine of 4x divided by the constant 4. Now let us look at examples when sine and cosine functions are given with power 2. There is no direct formula for the integral of sine square x. For squared sine and cosine functions, we are going to use these double angle identities. So sine square x can be replaced with 1 minus cos of 2x all divided by 2. So here we replace sine square x with 1 minus cos of 2x divided by 2 dx. Then it's a simple integral. This constant 2 is taken outside. Since 2 is in the denominator, we move out 1 over 2. The integral of 1 minus cos 2x. Find the integral of each term separately. Integral of 1 is x minus, and the integral of cos 2x is same as we did here. The integral of cos 2x is sine 2x divided by the constant. Either you can leave it as it is, or you can simplify it more by multiplying 1 over 2 inside. Same way, we can also find the integral of cos square x. Here we can replace cos square x with the double angle identity 1 plus cos 2x over 2 dx. Same way, the constant 1 over 2 is taken outside. The integral of 1 is x plus integral of cos 2x is sine of 2x divided by the constant 2. We always divide by the constant written along with x. Here 2 is written along with x, so we divide it by the constant 2. Now let us look at the functions when they are given with odd powers. We need to integrate sine cube x. To find the integral of sine and cosine functions with odd powers, we just break them. We split the odd powers in such a way that one sine x is taken out and write the rest of function with even power. Then we convert this sine square x using Pythagorean identity into 1 minus cos square x times sine x dx. Let me give you a hint. Whenever you are finding the integral of sine function with odd powers, you use cos x as u substitution. So we plug in u as cos x. Taking derivative of both sides, we get du equals negative sin x. Since here we need only sin x dx, so this negative sign is taken on the left. Or you can say we multiplied both sides with negative sign. Sin x dx equals negative du. Convert this integral in terms of u and we get 1 minus u squared. Sin x dx get replaced with negative du. We simplify it little more. This negative sign get multiplied with these terms and we get u squared minus 1. Then take the integral of each term. It's u cubed over 3 minus u plus c. At last we plug in back u, which is cos x. So it's cos cube x over 3 minus cos x plus c. Next we are going to find the integral of cos cube function in the same way as we did earlier. So we break cos cube x as cos squared x times cos x dx. Since it's a cosine function, so we substitute u as sin x. we always substitute the reverse. For odd powered cosine function, we substitute sin x as u, whereas for odd powered sine function, we substitute cos x as u. First, we change cos square x into sin square x using the Pythagorean identity, and then substitute u as sin x. Now the next steps are similar to the earlier one. We convert this integral in terms of u. Sin square x get replaced with u squared, cos x dx get replaced with du, and then we find their integral. At last we plug in back u as sin x to get the final answer. Now let us look at this example where sine is given with even power, higher even power. When there are even powers, we don't split them. For the even powers, we use double angle formulas. First we write it as sine squared x whole squared dx, and then we replace sine squared x with the double angle identity, 1 minus cos 2x over 2 whole squared dx. We simplify it more, take the square of numerator and denominator separately. This 4 in the denominator is taken out. Then we expand this square. You can expand this square either using the identity a minus b whole square, or you can use FOIL to simplify it. I'm going to apply the identity a minus b whole square. So it's 1 square minus 2ab plus b squared is cos squared 2x. Find the integral of each term separately. The integral of 1 is x minus integral of cos 2x. The constant 2 is kept as it is. The integral of cos 2x is sin 2x divided by 2. The integral of this part is solved again using the double angle identity. When we apply the double angle identity on this part, angle get doubled. This angle 2x becomes 4x. So this identity becomes 1 plus cos of 4x all divided by 2. After taking out the constant 1 over 2, we find the integral of each term. Integral of 1 is x plus integral of cos 4x is sin 4x divided by 4. We simplify this expression by combining like terms. We can combine this x and 1/2 x. X plus 1/2 x gives you 3/2 x. Then constant 1 over 4 is multiplied inside and we get the final answer. Same way we can solve the integral of cos x raised to power 4. We write it as cos squared x whole raised to power 2 dx, and then use the double angle identity and solve it further as same as we did here. I leave it to you to solve it further. So in this video, we can see that for even powered sine and cosine functions, we use double angle identity, and for odd powered sine and cosine functions, we split them up and then use u substitution.